Welcome, guys. Right. Thank you for joining in and thank you for registration. So basically, the topic for today will be the shipbuilding, right? And it will be basically why we are interested in shipbuilding, not as a sector, but we will go to the nuances of this sector and why India need to invest more on shipbuilding, right? And everything will be covered in a detailed manner. So with the start, let's start with the. Kaustubh, do you want to start?
Many of us would have read during our lifetimes that shipbuilding, navy is not something that is new to Bharat or India. We have had a glorious past, and we would just like to start the session with a few minutes on that. So while the shipbuilding theme is gaining prominence now, especially from the geopolitics and the investment side, it is important to know India's historical context, which can make us proud. So in the 7th and 8th century, the Pallavas laid foundation of the Tamil naval power, and it was Maharaja Rajendra Chola who transformed the navy into a truly aggressive, unbeatable cross-ocean force. So his time was from 1014 to 1044. So for context, Vasco da Gama's expedition started in 1497. So almost like 400, 500 years after Rajendra Chola was already having blue water navies. It is often cited as the first organized expeditionary navy in the world, what Cholas built. So they had a blue water capability, which means unlike most navies which are coastal in nature, local in nature, his navy was a transoceanic one capable of operating in deep oceans away from land for months. His most famous expedition in 1025 across the Bay of Bengal, over 1500 miles, which attacked the Srivijaya Empire, which is the modern day Indonesia and Malaysia. So this required complex logistics to carry fresh water, multiple food provisions, elephants, horses, etc. across the open sea. So they had advanced ship types to do all these kind of expeditions. Shipyards built specialized vessels for different roles. The Kaloni or the Kolandia were massive ships, first of their kind, used for long distance trade and troop transport across Southeast Asia and the Ganges. They had multiple masts and carried heavy goods. The Sangara was a twin hull ship which provided extreme stability in high seas and rough seas due to their design innovation prior to the modern day stable hull designs. And they are the Manime Thalai, ships that could carry smaller boats within them, called Padabu, effectively acting as landing craft carriers to ferry troops from main ship to shore. So, how was all this possible technologically? So, unique engineering technique, which is relevant even to modern sustainable shipbuilding discussions. No iron nails were used since they could rust or crack the wood under ocean water pressure. They drilled holes in the timber and stitched the planks together with coil or coconut fiber. This was called the sewn plank technique, which gave the hull flexibility to ride over waves without breaking. Unlike even many centuries later, the rigid European ships of which were prone to snapping in storms. And typically, durable tropical woods like teak and jackfruit were used. Also, they had a professional naval organization to boot, so not just a collection of ships and boats. It was like modern navies with a clear hierarchy. The inscription mentions specific naval ranks like Jalathali which is the commander of the fleet, and Kalapati, the ship captain, and so on. So, three strategic areas as a navy they controlled. Bay of Bengal was converted into a Chola lake. They controlled the entire part of it, and they had ships, boats all over. By controlling the Pok Strait, which is between Bharat and Sri Lanka, and the Malacca Strait near Malaysia, he effectively controlled the two most critical choke points of the global sea trade, allowing to dominate trade route between China and the Arab world for decades. And the mention of our history is not complete without the Maratha Navy under Chhatrapati Shivaji Maharaj from 1650 onwards, about 375 years back, which was a masterclass in asymmetric warfare, using local geography and the speed to counter technologically superior enemies. He is widely called the father of the Indian Navy because he was the first Indian ruler of that area to realize that he who rules the sea rules the land. Jalam jasya, balam tasya. How he built the navy? So actually shipyards were built between 1654 to 1658 around Kalyan, Bhiwandi and Goa. Utilized local resources, specifically high quality teak wood from the Sahyadri forest, which was durable and resistant to saltwater decay. The fleet composition was also of multiple types of ships and boats, which was Gurabs, which were heavier ships for with cannons for direct combat, Galbats, fast maneuverable assault boats used for chasing enemy ships, Sangaris and Manjuas, smaller boats for shallow creeks and transport. The recruitment strategy was called the Bhumiputra strategy. Instead of relying on foreign mercenaries, he recruited local seafaring communities like the Kolis, Bhandaris, Agris, and these men knew the treacherous reefs and tides of the Konkan coast better than any invading European ship or sailor. It was a very strong coastal defense force designed to neutralize the advantages of powerful invasion. So, unlike the Mughals who relied on Siddhis or the Europeans of naval support, this was the first indigenously built navy in the recent times. So, against the Siddhis, again, there was guerrilla warfare where the Siddhis were controlling the Janjira forts, and by building a counter fort called Padmapur, Shivaji Maharaj's troops never allowed them proper supplies from the land and hence prevented any invasion directly on the Konkan coast. Against the Europeans, they had the shallow draft advantage, where European ships were huge and deep drafts, they needed deep water. And Shivaji's ships were flat bottomed and shallow drafts. So they were lured into the creeks, which were shallow, and then swarms of small boats would attack from all sides. Also, he broke certain licensing monopolies. So before him, the Portuguese were already forcing Indian ships to buy a pass called Kartas. Shivaji challenged this by issuing his own passes and attacking Portuguese ships that refused to pay, effectively asserting Indian sovereignty over Indian waters. So that was a brief about our proud history. And Manthan, you can continue.
Right. That's insightful. Again, aim for the history was like we should always remember that like India used to have a strong navy, right, under the Chola Empire and the Marathas Empire, which is again often overlooked in our history books. So with that, we will move to the presentation roadmap for today. So what we will cover is the following. We will focus on the evaluation and the importance of shipbuilding, who dominates shipbuilding, how the shipbuilding cycles has been for last 120 or 150 years, right? This will help us in giving the context of where we are in the global scenario. Then this section will be taken by Amitabh. Then here we will basically focus on what actually is shipbuilding, right? How is the cost structure of shipbuilding and what government support is coming along, as well as the value chain of the shipbuilding industry. Then we will discuss extensively on the Navy part of India and how modernization is shaping up. So here we will see what are the different type of warships, right? How revenue booking cycles happen and what are the margin profile as per the vessels, what are the key risks, and the key companies that will be covered is all the three listed shipyards. Then we will move to the shipbuilding proxies or indirect beneficiaries like smaller companies. And again, there is one special situation in civil engineering which will be covered by Amitabh. And then last but not the least, we will move to the global commercial shipbuilding landscape. So we will structure it into two parts. One is on the Navy shipbuilding and the second part will be on the commercial shipbuilding. So we will cover cargo, ports, and some companies like Adani Ports, ABS Marine, and CMAC. So with that, let's deep dive into the start of our slide. So whenever we discuss shipbuilding, so shipbuilding mainly has two parts. One is on the naval or the defense side, and the second one is on the commercial side, right? And on the as we already know, right, on the navy side, it is mainly designed for defense, uh, then warfare, surveillance, or deterrence, right? We basically focus on the combat capability, survivability, and the long range missions. So the specifics of shipbuilding determines the end use of where the vessel will be used. While on the commercial shipbuilding, the ships or the vessels are designed basically for transporting cargoes, passengers, performing industrial operations, right, like tanker, ferries, and offshore vessels. So these are the clear two verticals, and going ahead, we will deep dive into both the sectors. Before that, we will see some commonalities between both of them. So let's start with the what is the global defense budget, and again, it's an estimated figures. So if you look at the India, the overall defense budget is around $86 billion, which sums somewhere around 7 lakh crore. However, if we look at the top nations like United States, China, India's military budget or the defense budget is pretty much some fractional of Chinese, right? And even in India, our defense budget, most of them goes for the pension and the other where we are not spending on the capabilities. So in the global context, if we see, right, US is spending somewhere around 17 lakh crore yearly on its defense budgets, right? That's how they have a massive global presence and the cutting edge tech that they have. Then even China has catched up very strongly in last 20 years. So they are spending yearly around 14 lakh crore, and it is estimated that Chinese defense budget will soon exceed US budgets in next 5 to 10 years. Then again, Russia spending pretty less on their army, but again they have a very good tech infrastructure. Yes, and as we already know, most of the Indian armors was made Russian made. But slowly now it is changing, and we are more diversifying towards USA and Israel. Plus, France is also the crucial partner in Indian defense ecosystem. So, with that context, let's move to the next slide. So on the slide here, right, we can clearly see what are the two different type of vessels, and there is a structural difference, right, in the design and the all the other parts. So like we have aircraft carriers in defense, then we have next generation missile vessels, we have submarines, then we have some patrol vessels, right? So these are the kind of the vessels that we see in the defense ecosystem. And on the commercial side, we have bulk carriers, where basically a lot of cargo that moves from one country to another is shipped through. Then we have oil tankers. This is specifically for transport of oil. Then we have dredgers. Again, we will cover this in detail in our upcoming slides. Then there are tugs, special purpose vehicles, and again, this is electric passenger ferries. Right? So these are the different two types of the vessels. And again, if we look at, right, there is this barrages and electric autonomous vessels also. So if we look at, right, which country has the highest Navy fleet by tonnage, right? So there could be things. So basically, this tonnage is basically how much amount of weight the individual Navy can carry on the ships. It's like that's how it's defined. So US has the highest capacity, or the we can say the most powerful Navy in the world, as we have already seen from the defense budget that they are spending, followed by China, Russia, Japan, and then comes India. So this is the top 10 nations which have the highest navy by the tonnage. And it is interesting to see like countries like Italy and Turkey in this list, because we like as a normal guy, like we usually think it should be dominated by France, UK, and other things. So coming to the next slide, if we look at like which is the top 12 biggest shipyards in the world. So basically, if we look at it's the highest or the biggest shipyard is in the South Korea, which is of Hyundai Heavy Industries. Then we have some Chinese, again they say that Chinese state-owned company, CSSC in Shanghai. Then we again have again two or three more South Korean companies, right? And then Japanese. So by this looking at this highest shipyard, we can clearly see which company or the which country dominates the shipbuilding or the shipyard capacity in the world. So it's South Korea, then China, and again, we have one company which is Masgao Dock in top 15. So we have a long runway for the growth. Now let's look at like who dominates the shipbuilding part. So here, if we look at the total global world ranking, so the total capacity or the on US only makes somewhere around 0.1% of the total ships, right? And it is predominantly dominated by China, then South Korea, and Japan. The interesting thing here is both of like all the three companies are the Asian countries. So Asia basically dominates the shipbuilding thanks to China, then South Korea and Japan. Again, Japan market share is decreasing. We will see in the subsequent slides. But Asia dominates it, but yet India is far behind in this race. So here we are basically talking about the commercial shipbuilding. So how many ships are which by which company, which countries? So around 50% of the ships that are currently uh, by which the global trade is happening is mainly built by China. So that's the scale that they had. And India, again, is not even in the top 20. So briefly looking in the next slide, right, we will look at the history of the shipbuilding and which company used to dominate. Yeah. So if we look at the history of the shipbuilding, so post World War II era, right, this entire shipbuilding was dominated by the European companies. Then in the 1960s, the shift to the Asia began. Basically, why? Because the high European labor cost in the Europe has increased, which allowed in Asian countries like Japan to compete. Right? By 1970s or the mid 1970s, Japan became the market leader, and again due to the uh, aging population and the other things, by mid 90s, South Korea is to the top, basically due to the strong government focus. So strong government promotion helped South Korea to secure number one market share by 1990s. But since then, China was not even in the picture. So China basically in 1990 started working on their shipbuilding and came to the number two slot. Right? But at the end of 2008 and 7, basically China was increasing its market share, and this was the decade where rise of China in the shipbuilding was coming. Now, in the subsequent slides, we will see like how China is dominating the world shipbuilding capabilities. So in this slide, like if we look at here, China basically dominates the entire shipbuilding, and it's again we have discussed it's China, Asian dominated. So India only has 0.06% of the shipbuilding capacity. So again, it's a bad news, but again, it's a good news also because if India starts focusing on its infrastructure capabilities, the best would be ahead of us because we are already pretty much at the 20th position. And the goal of the government, as we will cover in the subsequent slide, will be to in the top five in next maybe 5 to 10 years. 10 years is very ambitious as for me, but that's the focus of the government. And we will again see like how much TAM it is available for Indian companies. So in the next slide, again, we will discuss why China, South Korea, and Japan are the market leaders, right? And so due to some reasons, again, there are basically so in this slide, if we look at it, so China basically dominates the shipbuilding as we've seen in the past slides. China has built more than half of all the global merchant ship that has been made till 2023. So they have the capacity of around 36 million gross ton. Again, we will discuss what this gross ton means gross in the next slide. But for the ease, right, we will see like again China dominates around 53% of the market share. It has the unmatched scale and the capabilities. Then they are the industry leader because there's a state-owned company which is called China State Shipbuilding Corporation. It's owned by Chinese government and they are basically heavily subsidized to make ships. And this is one of the largest ship yards in the world. Why Korea is competing? Because initially government supported this sector in the South Korea, and their excellence in engineering technology helped them to build certain technological advances. The industry leader is Hyundai Heavy Industries, right? And Samsung is also in the chain. So they basically manufacture high value and the complex vessels. The third part on the Japan. Japan is also uh, pretty much big in the shipbuilding, but as we have seen in the past slides, Japan market share is reducing because of the increasing labor cost and the shortage of the labor that they have. And Japan is the oldest country. So in shipbuilding, we basically require two things. One is the abundant steel that is required. Second is the abundant labor because shipbuilding is a labor intensive industry. So we need a lot of laborers to weld the hull of the ship, right? And Japanese, as it's being the oldest country in the world. So they have a huge shortage of manpower. But again, they have a company called Mitsubishi, which is specialized into LNG carrier. So this basically transport liquefied natural gas across the nation. So they have a specialization there, and they manufacture energy efficient ships. So with that, again, if we see the annual growth rate of Japan is shrinking, it's by -3, and South Korea and Chinese shipbuilding industry is growing greater than around 20% almost. So that's the kind of the growth that we are seeing in the two countries, and precisely due to the reason why we are interested in the shipbuilding. So if government focus sustains, India can also see the similar kind of growth rates. So just because like we have discussed gross weight or the gross ton in the last slide, we will basically understand how the different ship capacity metrics are. First one is deadweight tons. So this basically measures the total amount of a weight a ship can carry, so which includes both cargo, crew, and the supplies, etc. So the total weight of the ship is called dead weight tonnage. Then there is a different category or different metric of measuring the weight, which is called displacement tons, right? So basically, if the empty ship or the only the weight of the ship when it goes into the water, how much water it displaces. So that's how it is measured. Then next one is the gross tonnage. So it's basically the how much volume of the goods it can contain inside the ship. It's not weight, it's basically the volume, how much volume of the material or the goods can be stored. That's the unit called gross tons. And the last one is compensated gross tons. So this metric is basically used to compare outputs of the different shipyards. because again, one shipyard can have expertise in building a certain type of vessels only. So we need a common factor. So that's how we use compensated gross tons. So in the next slide, we will basically go through the what are the shipbuilding cycles of past 150 years. So that will help us contextualize whether the industry is a cyclical industry or a deep cyclical industry. So on this slide, right, this is a graph or a cycle that represents last 150 years history, right? And this cycle, this graph basically helps us understanding what is the global shipbuilding cycle that has been in the past. So this red line basically signifies the total maritime trade that happens through the oceans or the waterways, right? And if you see, this red line is been increasing in a basically exponential way. So that means like basically the total uh, transport that is happening or the total trade that is happening is on a continuous increase. But the lower line on the gray side or the bluish side, this highlights basically the total shipbuilding capacity in the world. And if you see on a long term, it's increasing because it need to go with the total global trade that is happening, but it has its own peaks and troughs because this cycle or this industry is a highly cyclical industry. However, this whenever it's a deep cyclical industry, I would like to call. So whenever it's an upcycle, it lasts for 3 to 5 years at least, and then it goes for a silence. And that's how it is very important to understand. So if we start it from like around 1990s, I'm not sure why my cursor is not moving. Yeah. So if we look at from here, right, in 1920s, we had a one peak, right? Basically, it's due to the rapid growth in the sea trade. But again, it fall because of the Great Depression that had happened. So if you see that the total shipbuilding capacity is directly determined by the supply demand economics also. Then in before basically the WWI, the First World War triggered the shipbuilding demand because a lot of things need to be transported. So that's led to the huge growth, which we call it peak seven here, right? And what happened post World War? Basically, this demand got collapsed, and that's how the shipbuilding demand get also get collapsed. But after that, we have seen post World War II, right? It has been a post World War II. The trade, lot of things happened in the world, right? Because a lot of negotiation has been done, a lot of global institution being set up, which led to the confidence of the global trade, and that's how the global trade ecosystem started booming again. So if you see, this red line is again increasing in a continuous way, and that's led to the shipbuilding increase in the shipbuilding capacities also. So this is the time where a lot of all the shipbuilders into the world gets a lot of orders. These are pretty much the area where, as an investor, we should focus on, right? And we should try to find only when we see a clear tailwinds of the order books. Because once we start getting order books, then this cycle sustains for 5 to 6 years. That's been the history. And then again, if you see there is a huge collapse in the shipbuilding capacity or the total ship that has been made. So that sees the element of the deep cyclicity into the uh, industry at a global level, right? And then we see a peak of 2008 because a lot of things happened from 2003 or the late 90s till 2008, right? And that led to the massive trade growth and the yard expansion. So what happens into the good cycle? All the yards or the shipyards make a lot of capacities. They do a lot of expansions. Once the demand slows down, not I will not say even collapse, it starts slowing down, then the entire thing goes downhill. So in the till the COVID time, we were in the lull period of this down cycle. So it lasted for more than 10 or 12 years, right? But post COVID, we are again seeing an increase in the shipbuilding capacities, and a lot of the global players are getting a lot of orders. So if you go to the some Korean companies, right, they mentioned right they cannot even take any order now. They are fully booked for next 2 to 3 years. So that has been the case into the shipbuilding that has been uh, since 2021. So what happened during this lull period? A lot of the shipbuilding capacities that across the world was basically closed because they were not getting the orders. There was one fact that I read is basically only 40-45 shipyards got a order above a certain threshold. So most of the shipyards went out of the business because they were not able to compete. There was lack of order book into the segment that led to the consolidation into the industry, and that's how Chinese players started emerging. And now, once the demand is back, there are a handful of the shipyards that can manufacture ships at that level. and even Chinese companies are fully booked for next 3 to 4 years, right? And even there are certain order that's also flowing into the Indian markets, and we have seen some Korean companies being doing MOUs with the Indian companies, right? Just because India has both the thing that is required in the shipbuilding segment. So somewhere we are here in this cycle, and we think again as per the graph also we are in a huge shipping upcycle for at least next 5 to 10 years. Now, in the next slide, we will basically look at the shipbuilding by market segments. So, where we will understand, right, what are the different, how we can categorize shipbuilding markets. So, into the this segment, right, if we see on the top left hand side, right, we see a ship type. So, we have a cargo, we have vessel, then containers, right, and a tanker and a multi-purpose ships. Right, these are the basically a market segmentation by ship types. And then there is a market, there basically a propulsion. So how a vessel or a ship, basically a ship, how it get propelled over a distance, right? It's basically driven by a conventional diesel engine. Now gas turbine is coming. There are certain vessels which are nuclear powered, and in the new thing, it is on the electric and the hybrid kind of thing. So on the propulsion side, there are a few interesting companies again that we can discuss. Then on the by the process side, we have different kind of processes by which like the ships can be made. And last but not the least, it's again the end use of the vessels. So as we have discussed earlier, also it's basically commercial and the military part of the segment. Now we will look at like what is the importance of the shipbuilding. So basically shipbuilding importance is, so why we are discussing shipbuilding today. Again, this has been a maybe kind of an essence of why do we want to cover this thing. So if you look at it around, India basically accounts for 2% of the total world tonnage, right? So the made in India ships are pretty less, but India spends heavily on leasing the ships from outside. So that amount is basically $75 billion, which is roughly around our defense budget, as we have seen in the past slides. Right? So that's the amount that India is paying to the uh, outside countries for leasing their ships. Right? And primarily, we are expecting, or the government is expecting, this outflow to be somewhere around $100 billion. Right? So that's a huge fiscal deficit pressure that government is facing because a lot of Indian companies are spending money and which is going out of the nation. And India basically has only 1.2% share into the global ownership. Right? Again, these ships are basically leased into the countries where they get tax incentive. That's how we are seeing Greece here. And India only accounts for 0.77, less than 1% of the global registered ships in India. Right? Again, most of the ship registration has been in the nations like Libya and Panama for the tax advantages. So that's the thing because India is spending a lot of money on the lease part. So government is thinking why not start building their own ships so that we can save or basically at least flow in this kind of money in the Indian economy directly. And this also has a strong, basically kind of a reliance on the Chinese thing. So in kind of any mishappening, right? Again, we are using Chinese vessels, and if we China start or the China stops giving us the vessel, that could be the main black swan event that can happen, right? All the trade can collapse. So relying on the external power for critical maritime assets creates unacceptable risk, right? So what if like we have seen US has already put a lot of sanction on the Russia, right? So even on the shipping on to the Russia, there are certain sections. So if the company is supplying uh, vessels who supplies cargo to the Russia, that company or the ship owning company will also get sanctioned. So in these kind of cases, right, we do not want to rely on the third party vendors because no one will uh, try to bear the US sanction threat that they have. So basically, we or the India needs to have a certain market share. We need to have our own ships so that we can secure our trade. Then again, this is the strategic rival. China is controlling 53% of the global market, right? Again, it's a sovereign shipbuilding capability. So India को basically national security के purpose से भी shipbuilding के ऊपर अपना basically more focus करना पड़ेगा so that we are totally integrated and insulated from the global shock as much as we can try. So like we need ships for oil tankers because as we know, right, all of the oil is transported through ship route only. Then there are container ships. So if you want to transport your textiles, your pharmaceutical things, right, all of these things are shipped via waterways. So that's the container kind of thing. Then there are pearl carriers and offshore platforms. So there are a lot of things where ships are required. Around 95% of the total Indian trade happens through waterways, and we are incurring a lot of uh, outflow for this money. So can India make ships? Right. That's the again the second pertinent question that we can have in our mind. So the answer lies in if we can build this. This is INS Vikrant, right? Then we can build anything. So this is the first indigenously made aircraft carrier. This is the most complex vessel that we can see. It's a movable island kind of thing, if we can assume. It's uh, a huge vessel. Again, nothing like comparison of US aircraft carrier because they are humongous. But India has made it first thing, and India may be working on the third one soon, right? And India is the only one of the six nations which has achieved this to make indigenous aircraft carrier. The only other countries that have made this is US, UK, China, Russia, France, and Japan, right? Then India is basically manufactured around 54 new warships for Indian Navy, which is currently being built. As we have also seen one of the interview of Mr. Prime Minister Modi, that we are getting a new vessels in our Navy in every 40 days. So that's the scale that we have achieved in the defense part, right? And all of this thing happened in the last 5 to 6 years. Right? So do we have what it takes to build ships? So what it takes to build ships? So if you see in this diagram here, right, there is a huge ship thing and the person is welding. So that's the pretty much essence. So you need two essential things. One is young labor who can weld thousands of hours of welding, right? So that's for that we need a young labor force. Second one is we need marine grade steel production. So India is already second largest producer of steel. So we have abundant steel available. We have abundant young force that can help in or that can be catered to shipbuilding. What we require is the proven high-end skills. We have proved by building complex ships like aircraft carriers and nuclear submarines, obviously with the tech transfer. And the similar capability we need to develop as a nation for the commercial shipbuilding. So these are the three elements which is required. India already have two parts. We just need to focus more on the training part of the thing. So we have seen a lot of the top shipyard companies, basically Masgao, GRSC, and Cochin Shipyard, had a huge rally since 20 in the last 2 or 3 years, right? And why it happened, right? Because if you look at the order book size, right, it has basically kind of a tsunami of naval orders that has been come. And again, there is a lot of around 2 lakh crore of the total uh, new orders that is being lined up for FY 26-27, right? So if you look at the on the left hand side, there is a graph where we have done the combined order book of all the three shipyards, and if we see it's a huge order pipeline that is there, right? That's the kind of the visibility that these navy companies have. So government is trying to focus. India currently has only 132 vessels for the warships. India want to have 200 power of warships by 2035. Right. And basically, the total estimate of the orders that we expect is basically around north of 2 lakh crores. So, and then again, why we need to build our own ships? So, basically, building ships is equals to building the nation, right? We will discuss it why. Because when you spend rupees one on shipbuilding, it generates 1.82 in the broader economy. So, that's an economic multiplier. Right? It creates 6.8x employment multiplier. So it creates large scale jobs because we have seen it requires a lot of welding parts, right? So it's a huge employment generator for the country. And with the boost on Indianization, it will also uh, help basically a lot of MSMEs where they can make different small components which caters to the shipbuilding. Again, we will cover few small companies in our section later, but that's the kind of the opportunity that we have. So around if we focus on Indianization, so a lot of SMEs can also be involved. What is the proof of concept? Basically, when we made INS Vikrant, our first indigenous aircraft carrier, basically 500 MSMEs was involved. 12,000 ancillary industry workers were directly uh, influenced, like they directly worked on the INS Vikrant, and 2,000 shipyard employees got paid. So that's a scale of one aircraft carrier uh, that has done to the Indian economy. So if we build focus on more on the shipbuilding part, including the commercial shipbuilding, that can lead to the economic growth for the country. That's how building ships is equivalent to building the nations. So again, India now like we need to see what's changing. We will cover all the government policy changes that happened in the past. what's happened in the past recently, what are the changes. But one more interesting thing that we are seeing is India is calling for the joint venture or the MOUs with the South Korean, the Japanese company for building shipbuilding clusters in India. So this is what we said. At least three states have expressed interest in providing land for establishing shipbuilding and ship repair clusters in India. This is by the Secretary of Ministry of Ports. So states are also incentivized to start building this ecosystem because it's a employment generator. Again, every chief minister wants to increase their uh, like they want to give more jobs to the youth, and shipbuilding could be the one industry where this can happen. So, what our Defense Minister Rajnath Singh ji mentioned, we are capable of delivering everything from aircraft carrier to advanced research vessels to energy efficient commercial ships. These are the integrated capabilities position India strongly to become a global hub for shipbuilding. So, whenever we are seeing these kind of statements from our political segment, so we understand there is a political will, and as we have seen in the solar thing also, a lot of incentives has been given by the government. So now government is focusing more on the shipbuilding part. So it could be we are early into the cycle, right? We need to see things happening at the ground. DPSU, basically defense PSUs, has a huge order book, but going ahead, we need to focus more on building the ecosystem, like the way we built into the renewable part. So the next thing here is uh, this is the thing where the entire crux of this session lies. Again, we will deep dive into a lot of companies, a lot of segment on the later part, but this is basically the shipbuilding value chain. So if you look at it here, right, let's start with the hull. Hull is the bottom of the ship. Basically, it's a structural steel. So a lot of steel is required. The companies which cater to this part is basically SAIL, Tata Steel, JSW Steel, right? And there's one smaller company is named Krishna Defense, and Amitabh will talk in detail about this company. Right? Then there is a specialized alloy manufacturer. Again, it's a PSU company, Mishra Dhatu Nigam. So they manufacture some titanium alloys, which goes into the defense segment. So again, it's a very niche or the specialized thing that this company makes. Then there are a lot of piping tubes and fitting players like Jindal Saw, Maharashtra Seamless. So a lot of steel pipes are also used into the ships, right? And there is one special company again, which is not a special. It's a used to manufacture castings, right? So Simplex Casting also got a small order from SGOV recently for some casted project. So then we will move to the propulsion type or the engine and the gears. We will have a Triveni Engineering. Again, it's a very beautiful case study that we will cover. Then they basically manufacture gearboxes. Then Cummins India is there. Then Kirloskar is there, which basically helps in the engine part. Then BHEL also manufactures certain parts of the engine. Then we have pumps and valves as a proxy, right? Here we have Kirloskar Pneumatics, KSB, Questflow. Again, we will cover Questflow later. Then we have rapid valves and the L&T valves. So on the ships, on the defense side, now we need our defense capabilities also. So we have companies like Bharat Dynamics, which is directly owns a lot of platforms. Then we have Solar Industries, L&T Defense, Premier Explosives, and Zen Technologies. So Zen Technologies is basically making uh, simulation devices for Navy. So that can be again an interesting play. Then if we will move to the electronic part, because again electronics is also essential part. We need a lot of radars and the electronics on the vessel, both in commercial and the Navy. But Bharat Electronics is the main company which is catering to this demand. Then there is companies called Data Pattern, Matter Technology, Restra Microwave. There is one small company, CFF Fluid, which is basically indigenizing the sonar. So a lot of the sonar was imported earlier. Now this CFF Fluid, with a tech transfer from a French company, is working on building indigenous sonar. So if that gets successful, then that could be an interesting play. So now ships also need both batteries and the energy storage, right? Even if it's electric powered or other, we need certain kind of energy storage inside the ships. So one company that caters to this is HBL Engineering. So we know this company for railway, but there was substantial part into the submarine batteries also. Then there is something called Exide and the Amara Raja here. Then coming to the electrical power and the cable distribution segment. So we have a company named Marine Electrical, which manufactures certain things which goes into these components. Then Apar Industries also make marine grade power cables. Then Polycab, Kia, which is again usual power companies that we see. One interesting part that here it is into the cooling and the ventilation segment. So in this cooling and ventilation on the ships, we require specialized cooling mechanisms. So the company that caters here is Voltas, Thermax, Shree Refrigerants, and United Heat Transfer. So these are the list of the companies that are pretty much placed into this value chain. So here we have named somewhere around 40 plus companies, right? So that you can understand which company are in which value chain. Again, we will cover a lot of companies from them. These are the shipyards, which we'll cover in the later part. But this is the slide that will give you idea of how this ecosystem is placed. So I would like to invite Amitabh if he wants to share anything on this slide.
Yeah, thanks, Vanthan. So this slide is really interesting because we would like to see the whole value chain, even though we try to cover whatever we knew. And the list is actually longer if we put up unlisted companies also. So we try to kind of give you a comprehensive view of this whole value chain. And in value chain, we'll also talk about the cost later in slides. So when we talk about cost, then we'll realize that how much of this will go into that typically. For example, walls is an interesting play where around when we make a ship of, let's say, 100 crore, then around up to 3 crores, 1 to 3 crores is typical, the cost, typical absorption of walls in a 1 crore, in a 100 crore ship. So typically that kind of equation goes into it because number of walls making use for making a ship is huge. It's in 10,000 or something like that. So it's like the way we talk about in automobile, there are so many fasteners. There are thousands of fasteners goes into an ICE engine car. Likewise, valves are like the building unit of these huge ships. Likewise, if you go to specialized players, like just to give you elaborate with one example of Shree Refrigeration. So, and let's say United Heat Transfer. So these are United Heat Transfer is basically is a company which makes heat exchangers for which goes into making of HVAC and other stuff which of shipping platform. And so that is a very unit level company which is whose output goes into this value chain. Shree Refrigeration is a kind of a component or slightly bigger than a component, we can say a module level supplier. So Shree Refrigeration basically built up the refrigeration part, which is very complex in submarine systems, and it is something which not a typical HVAC player can do capability wise. So it requires a specialized ambient control of temperature, and when you apply for a shipyard approval for a ABS certification or any registrar shipbuilding registrar certification, they look for all these nuanced matrices like how much temperature is controlled, how much oxygen is there in the air. So those things are very precise, and that's why expertise of that's why an expert can only do that. And in a similar fashion, there's a company called Marine Electrical, which is also an expert, which is expert of making switch gears, just like Schneider, and they work with Schneider. That is 50% part, but 50% of their business goes into shippings and submarines again. Likewise, the way I mentioned about Shree Refrigeration, so they are expert into control systems and electrical panels, and there are many electronics based systems into shipping which is there to control the vessels from inside. So those things are being built by Marine. And again, I've got a similar feedback from one of their competitor of Marine Electrical that that they don't go into shipbuilding because it's a very complex, because the environment itself is very daunting to put a parameterized output. So companies in this value chain have to be an expert of this domain. It's not that is not just like a road building thing that you are eligible, that the government will allow you to build roads anywhere. It is very specialized job. So that's why specialized builder or specialized companies sometimes demand specialized valuation, and that's what we sometimes see. For example, we are seeing a kind of a good valuation multiple given to Shree Refrigeration, just for example, not a recommendation. So likewise, we have to understand why market is giving multiples to them, because they are building something which is unique and where the TAM is rapidly increasing. So all these small players become an interesting play, and which we'll cover later. But for now, Manthan, we can move to the next slide.
Yeah.
Let's talk about the overview of this process, which is called shipbuilding. So the building part, the manufacturing part. So what you can see in the picture itself is a very complex job. It's like a project, and it's one of the typical longest cycle project which I can envisage. Like I've worked in automobile where if we have to build up even a largest plant you can make in 2-3 years. It's the maximum you would take to build a plant. But to build a ship, sometimes it takes 10 years, 7-8 years. So it's a very complex affair, and it requires so many man hours that it becomes a daunting task. That's why you can see only 3 large countries have seriously given it a thought that let's build a shipbuilding yard, like India, China, and Korea. So the process we need to understand so we can appreciate when we will be fully ready to get the market share which India as a country wants to acquire, as mentioned by our Prime Minister and supported by Ministry of Shipping and Port. So typically we can distribute this whole process. Yeah. Sorry. Let me just. Yeah, so the shipbuilding is not just about constructing shiny new vessels. It's basically 3 businesses rolled into one. That's why it's very complex and the gestation cycle are so long. First is building part. When we build, it's a huge manpower intensive work. Then second is repair and maintenance, which is also a big business because the life of a ship is typically at least 15 years. So after 15 years, somebody think of replacing it or doing it. So 15 to 20 years is typical life cycle. So the repair and maintenance during those 15 years is very tricky because whenever a ship goes into ocean, there are many uncertainties, the tide and everything, and the icebergs. So hidden icebergs could be problems. So which we have seen in many cases when we look at cases like Titanic, and also the repair and maintenance is a very important part. And third is recycling, because this ship itself is a huge volume of iron and steel and so many materials. So you cannot just waste a ship. So जैसे there's a Hindi adage कहते हैं कि जैसे एक जिंदा हाथी लाख का होता है और मरा हुआ हाथी 1.25 लाख का होता है. So likewise, this ship is like the dead elephant, which itself carries value because of its material, the metals inside it. So 3 processes built into one. So first step is so as I said, it's at least 3-4 year cycle when we talk about 2,30,000 crore of TAM of shipbuilding. So actually this TAM will involve a building stage mostly, and I spoke to a commodore who said that typically it takes at least 4 years. On an average, we can say 4 to 5 years. May this 2,30,000 would be exhausted. So we can just divide the TAM into by 5. So roughly 50,000 crore of shipbuilding opportunity, we can loosely say, but the cycle would be different. So because this cycle involves the ordering, so once we decide that okay, we want this gross weight, then order is put up, and especially I'm talking about, let's say, defense naval orders. So it takes slightly more. So first order is placed, whether it is going to GRSC or L&T, that decision takes around 6 to 9 months, up to 6 months is minimum nowadays. So once a PSU or the main guy is decided, he takes another 6 months to finalize whether the HVAC will go to Shri or Snyder or whoever. So they take around 6 months more. So starts moving on the ground after 1 year. So that's why building is itself 1 year. 1 year may nothing moves faster because it also involves designing, and then after 1 year you go to the assembling the ship from scratch, like doing the welding part and all. So after 1 year, equipment starts adding in. So 1 year is typically the starting point once we hear the news that this ship is to be built. And once building cycle is done, then repair and maintenance cycle starts. So this 20-30 years is a lifetime for them. So it regularly involves mandatory surveys, overhauling, and retrofits. So retrofit is also an important part of this value chain. And last leg is the breaking part, the recycling part. So when the industry says that okay, this ship is kind of is energy inefficient, so it's better to break it down rather than carry it, because maintaining a ship is very costly affair. So there are ship breakage yards where we dismantle these ships and their steel is sold back into the market. So there is a place called Alang in Gujarat, which is Asia's largest ship breaking yard. So India already have a foothold into recycling sector, And that's why when Mr. Modi went to US for bilateral negotiations around 6 months back with Mr. Trump, he was heard talking about that US should drop their ships in Indian Ocean on the western part, and India will take part into dismantling it and reproducing the new ships from there. So that's the India's pitch is to USA and other player who probably would be buying ships, because US doesn't make any ship in-house. So India is proposing to take a piece into their dismantling process and henceforth into new orders. So that's a very strategic move by government. So let's take a view of how much typically a ship cost. What is the breakup of a typical ship? So we can bifurcate into 3 segments. One is the marine equipment. So as ships are made of complex instruments, which needs to operate under humid conditions. So the marine equipment is actually the costliest part, which has more than 50% weight into it. It actually includes the engine, which is a very complex part. Then we need to maintain power, so auxiliary power equipment, which takes care of all the lighting needs and AC needs of the resident who are residing on those ships. Then deck machineries and other specialized ship equipment machineries. So these things are the most important part of the typical ship, and it is roughly half of the total cost. Second is the usual suspect, that is raw material cost, which is 25%, which basically encompasses steel, alloys, and welding materials, paints, and auxiliary materials. And typically the steel hull construction, which is one of the main thing for main part of raw material, it kind of costs around 25% of raw material cost. So it's like 1/4 of 1/4. So 1/16 of the total cost. And labor cost around 75% of the hull related expenditure. So hull being one of the important piece. So that goes under raw material cost. And last leg is labor cost, which is 25%, another 1/4. So they require huge manpowers to build a ship, and largely into cutting, forming, assembly, welding, and finishing related activity. Basically, it's a fabrication job. So it's the largest fabrication job you can think of, and typically, as every metal fabrication requires welding and assembly and forming, cutting, and also it is largely here done through different labors. So it's not automated. At least in India, it's not automated, and worldwide also, because every ship has required different dimension. It's not a standardized item like in India. It's not like automobile. Like Henry Ford has kind of systematized all the parts. That okay, there should be a standardized thing. So that's why assembly line become a very wider concept into automobile and copied by other manufacturers also. But this cannot be done into shipping. That's why the labor cost is very high into this business. So let me give you a comparison of where we lag in terms of from the 3 companies which was mentioned in today's presentation. Largely, we talk about China, Japan, and South Korea. If we take we try to differentiate this whole cost into 3 parts. And we are adding financing also. Why we are adding financing as a leg here? Part of a cost leg, because making of a ship involves at least 3, 4, 5 years. So during that time, you need to give labor their salary, and you need to purchase many things in advance, and those inventory has to be funded. So for the cost of financing is a very large portion of a total project cost of a ship. And typically the material cost, as I said, that if we add the raw material as well as the equipment material, it goes up to 70% of vessel cost. So if we benchmark India against China, so this how this table work is that India is almost 100% into this all 3 parameters. So basically 100% represent that what India takes 1 rupee to make steel. So China will take 90 paisa to make that same portion. So likewise Korea and Japan also. So we can see that on a relative basis, India is 5 to 10% costlier than rest of 3. Then in other material also, we have a larger gap to fill. We are 15% costlier than typical China and Japan. And relative cost basis, we are typically 12 to 13%, 10 to 12% costlier in raw material side. But if you go into labor, we think, and we proudly think, that we are very cheap labor country. But if we adjust this with a productivity, so labor rate could be cheaper, like $3 to $4 per machine hours, which is half of Chinese and 1/4 of South Korea, which is kind of advanced country. So obviously, South Korea, Japan, their labor costs are high, but their productivity is also better. So that's why if we multiply this labor rate with productivity, we stand 2 times costlier than all these three, including China being the cheapest, which is 50%, 52% cheaper than us. So it's like we cost double to China and almost equally double to Korea in terms of making labor cost as a proportion of the ship. So that is the starting point, which we are kind of very much behind into labor side. So we need to do skilling of the labor, because our labor are not skilled, and our processes, our equipments may need upgradation, and these requires capex investment. So yards might be needing improvement in terms of machinery, so that labor can be equipped. And that's why doing MOU with South Korean companies like HD Hyundai and all, that would pave way for our industry to move forward into this productivity curve. We are a developing country, and most of the three are kind of developed. So our cost of fund is basically higher, 10 to 11% of typical interest rate, against very low, around sub 5% rate into China and Japan are almost negligible. Now Japanese rate has gone to 1.8, 10%, 10-year yield has gone to 1.8, 1.9%, but still it is around 2%. And Korea is also into 2%, and China is into up to 5%. So we are 2 times costlier in terms of financing, and that's why these things are being taken care of. So financing is one aspect where I see government is seriously putting effort to reduce this gap, and this is quite possible by government intervention to a certain extent. So the total cost of ownership is, if let's say India is making a ship into 100 crore, then China would be making it 74, and South Korea would be making it 78, and Japan would be making it into 79. So relative basis, we are at almost 23, 25% costlier than these three biggies. So this is the overall picture we should be looking at when we are kind of placing ourselves and aiming to be into top 5 shipbuilding nations of the world. So India's vision of 2030 in terms of shipbuilding is that we would like to grow many-fold, and it would happen into 2 legs. First leg is already done, 2020 to 2025. So when we started doing by annual production of 30,000 gross tonnage, target is to reach a critical stage of 100,000 gross ton, and then to make it 5x from there in next 5 years. So 2030 aspiration to be in top 10 in shipbuilding is to make 5 lakh ton plus gross tonnage, which is a huge task. So how we are trying to go to there is step 1 is that to provide support through domestic demand, both cargo and non-cargo. So domestic demand, basically to increase domestic demand, we have seen some regulation like gross tonnage, like India has given an infrastructure status to shipbuilding. I will talk about that into detail. That will take care of domestic demand to a certain extent, and vessels that can be built readily and at international prices in India. So the thirst is on making in India. So it's a part and parcel of the Atmanirbhar Bharat mission that is there. And in the second leg, we are trying to optimize the supply chain ecosystem and scale this demand and supply to export market as well. But that is kind of a humongous task. To be competitive for export market is slightly ambitious, which I think is not achievable by 2030. Because that requires a different kind of support, and the whole supply chain has to be ready for that. And right now we are not there. So if we look at the government support function, that what government is trying to do here, because as we said in our spaces also, that government is very serious about mission of making the cut into top 10 shipbuilding countries by 2030. So the future lies through 3-4 programs. So there are three important pillars. And the number one is the Shipbuilding Financial Assistance Scheme, so which has the solution to the financing trouble, where we lack against all these three. So there are financing assistance to be provided up to 25,000 crores, and there is a national shipbuilding mission. So these mission-related expenses would be supported by financial assistance scheme. Then there is a 25,000 crore equal-sized maritime development fund. So where India would be doing investments through maritime investment fund, and then there would be some interest incentivizing fund. So all these shipyards and all the ancillaries unit would be incentivized, and for that subsidies and potentially a PLI kind of scheme can be housed under maritime development fund. Right now, there is nothing that's not being discussed at PLI or something, but I am hypothesizing that this could be a fund through which this can flow through. Third pillar is shipbuilding development scheme. We'll talk about it, which is around 20,000 crore. And there are legal policy and process reform. I will mention the tax reform, for example, which is the pillar 4 of shipbuilding future. So this is an approach which I think Mr. Modi, alongside the Minister for Port and Shipping, Mr. Sarvanand Sonowal, has taken. So the Vision 2030 for maritime looks like this, that we would like to do an investment of around 3 to 3.5 lakh crore into this over 150 initiatives under the Maritime India Vision 2030. So actually 150 initiatives were actually proposed. I've seen the 300-page document of India Maritime Vision. You can download it from the internet. So actually there are 150 plus initiatives. And so the government has thought it through on ground. I don't know how much of it would really float on the ground, but at least the policy level thought process has gone through to make that document. And some of the schemes like a green transitioning of tugs, like green tug transition program, all these things are being applied now. So this document was made into 2021, and at least I could see colors, real colors into these frames, which were mentioned in through 150 initiatives. So I cannot vouch for whole 150 plus initiative, but there are certain initiatives which are seeing the light of the day, and that is a positive. So India wants to participate into not just defense, but on the cargo side as well. And India wants to handle as much as cargo as possible, because shipbuilding ecosystem would not grow unless we have a ecosystem of unless we have a market around it. So if people will come for handling, will be needing vessels for handling, then only our Make in India and shipbuilding initiative would actually would grow. So the cargo tonnage is 855 million ton, which is quite large. And there is a definition called India flagged vessels, where Indian flags are there. So the number has to increase from 1205 to 1549. So that would be the lever through which it will grow. The financial initiative I already have spoken to, that these three initiatives which are paving way for growth into this sector. So let's talk about one important development which just happened in around 2 months back, that this large shipping industries got an infrastructure status, which is a very important milestone, because when we look at these businesses, then it needs funding, and it needs not just funding for short term for working capital, which already is required, but also for long term funding, which is not possible unless we give them infrastructure status. Because once we give infrastructure status to any industry, it gives you access to the project financing. So project financing is a type of financing where the large projects, typically 100 crore kind of projects, they get funded basis the future cash flow, not basis the asset. So it's a contrast to the asset based funding to a cash flow based funding. So the way we invest into equity market, so they are project finance institutions, and sometimes they are bank also. So one erstwhile IDFC was a project finance institution. So now it's IDFC First Bank. So there are L&T Infrastructure was a project finance institution. So these institutions, they do the project lending for 15-20 years. That is possible. So that allows such ships to be used as collateral, enabling shipping companies and shipyards to assess lower cost and long tenure financing for new vessels order. So new vessels order would require two components for financing. One is the working capital for during the construction period, and for after the ships gets constructed, then they would move to project financing, or before that also they get project funding. But project financing will be helping this whole segment to kind of reduce the cost of fund, and actually there would be a banker to support this whole thing, and that is very important thing. And how does this help a bank to look at this sector? Because once it gets infrastructure status, then the RBI guidelines, they say that you can do a provisioning of 1% for infrastructure projects against typical 5%. From typical construction project, let's say if I am a Prestige or if I am L&T doing a real estate project, then if ICICI Bank lends to L&T, then if they give 100 crore to L&T, then they will have to provide for 5 crore in their balance sheet for a provision for this risk built into lending to a real estate. But this risk weight in a way of provisioning, to be precise, is 1% for infrastructure projects. So this gives a 5x lever for let's say L&T to do their shipbuilding more than their road construction project. So this is an incentive for these companies like L&T and Chapoji Palonji to get into infrastructure, get into shipbuilding and all, because for them funding would get easier and banks would be willing to fund these long gestation period rather than the shorter tenure projects of any EPC company. Apart from this, there is a concept of DCCO in banking, which is basically date of commencement of commercial operation, when the projects really get completed. So what typically happens, and in many cases, even we were trying to build submarine and we were trying to build airport, this airline carriers, and if you visit the timelines, so India wanted to have these ships ready in 5 years, but it took 10 years sometimes. So if you are funded by a banker, then after 5 years he will catch your neck that where is the money. But in banking system, there is a provision for being an infrastructure status. You have a provision for extension of this DCCO up to 3 years. So in typically, if a real estate project can extend their timeline to 1 year, but these projects can extend their timeline to 3 years. So the overall, these are the enabler thing which a banker or a project finance institution can provide to this sector. So that's the enabler for making big ships, large ships into India, which typically is filled with many risks. So that's the financing parts, and that incentive is given. Now let's talk about the policy side on the taxation. So there has been a very new definition change, actually, which is called a tonnage tax scheme. So actually this scheme was there long back, but in April 1, in last year itself, this year actually, they included their inland vessels. Inland vessels are defined as vessels which operate in India, nearby India. So it's catering to domestic demand. So these inland vessels from April 1, 2026 can take tonnage tax scheme benefit. So what the benefit include is that it is a presumptive taxation model. So it's presumptive means it's on an assumption basis, and the tax calculation is done before the year starts actually. So it's basically calculated on the basis of net tonnage of a ship, not basis on the actual profit. So they are incentivizing the making of an operation of a ship, that you should procure ships, don't worry about the making actual profit or not, because if you build up a tonnage, then your taxation, a liberal taxation would apply to you rather than how much profit you are making. So typically we pay tax from the actual profit, but here to incentivize all these ship operators, they have given a presumptive taxation model. So it targets ship owners, operator, and it's basically, but it's not very friendly to shipyards directly, because shipyards are makers of the ship, but operators and cargo operators are the users of the ship. So it's basically favors users over a maker, basically, because this is an operational tonnage basis, not on a construction activity. Other benefit include that the minimum alternative tax would not apply to these these ship operators. There are other activities allowed, like you can go for charter in up to 49% of owned fleet tonnage. Like for example, if you have a ship of, let's say, whatever ship vessel you have, so you can, out of 365 days, you can for 180 days you can let it go on the charter hire also, and for rest of more than 49% of the days, 50% of the days, you can run as a cargo operator. So that you will not lose the scheme benefit. And there are certain things which will reduce the tax burden, which encourage Indian shipping company to compete internationally. And just to give you an example, there's a company called Knowledge Marine, which will cover. So Knowledge Marine has their CFO has told in the interview that in FY27 the expected tax outgo would be 0, because they are availing this tax benefit. They are going to avail this. So PBT would be equal to PAT. So this would kind of give a fillip to investment into these sectors also, because once we see that the government is not willing to partake money from free cash flow of a company, then obviously it will give fillip to the valuation of this sector.